There is a rule in astronomy. The farther you look, the further back in time you travel. And the further back in time you go, the simpler the universe should be. We were told that after the Big Bang, there was silence, a dark age. That the first galaxies were babies, small, irregular, and timid. That it took them billions of years to grow. But the James Webb Telescope opened its golden eyes and saw something that shouldn't be there. It found gigantic, mature, and bright galaxies right at the dawn of time. It found planets that should be dead, and it found light that violates our laws of physics. Today we're going to explain why astronomers are panicking in a good way. Are we looking at a flaw in our telescopes? Or do we have to rewrite the history of the universe? To understand why this is a problem, imagine you walk into a nursery. You expect to see babies, right? Crawling, babbling. But instead, you find a 40-year-old man with a beard, a suit, and a briefcase sitting in a crib. That's exactly what the James Webb found. Meet JWST 14-0. This red smudge is a galaxy that existed when the universe was only 290 million years old. According to the Standard Model of Cosmology, at that time, the universe was a baby. It shouldn't have had enough time to gather so much matter. The problem isn't just that they exist, it's what they're made of. The Webb detected oxygen in these galaxies. And here's the key. Oxygen is only created when stars die and explode. To have so much oxygen so early on, entire generations of stars had to be born, live, and die at an impossible speed. Scientists call them impossible galaxies, or the red monsters. They have stellar masses of hundreds of millions of suns. To form this using the physics we know, they would need to convert 100% of their gas into stars without wasting anything. In the local universe, galaxies barely convert 10%. It's as if these galaxies cheated in the video game of cosmic evolution. If the galaxy shouldn't be there, what are those red lights? This is where things get strange. The Webb telescope has found hundreds of little red dots that don't fit into any category. They're too small to be normal galaxies, but too bright to be stars. There's a fascinating theory that could save us. What if they're not galaxies? What if they are dark stars? Beware of the name. They're not dark. In fact, they would be the brightest things in the universe. Catherine Fries and her team proposed that these stars don't run on nuclear fusion like our sun, but on dark matter. The idea is this. In the early universe, dark matter was highly concentrated. If dark matter particles collide with each other, they annihilate and generate heat. This heat would keep the star inflated like a giant balloon. We're talking about stars so big that if you put one in the center of our solar system, it would swallow the Earth, Jupiter, and reach all the way to Saturn. A single star shining as brightly as an entire galaxy. The craziest thing is that the Webb data shows candidates like JWST 13-0 that fit this theory suspiciously well. If confirmed, we would have discovered a new type of celestial object that uses an exotic fuel. It would be the first direct evidence of the nature of dark matter. But the Webb telescope isn't just breaking the past, it's also breaking the present. Let's talk about the Hubble tension. Basically, astronomers have two ways to measure how fast the universe is expanding. 1. By looking at the echo of the Big Bang, the cosmic microwave background. 2. By measuring nearby stars and supernovae. They should give the same number, but they don't. Before Webb, we thought, well, maybe Hubble, the old telescope, is measuring incorrectly because the stars are so crowded together and it's getting confused. Webb arrived with its X-ray, well, infrared, vision, and looked at those same stars with brutal precision to correct the error. The result? Webb confirmed that the previous measurements were correct. The discrepancy is real. The universe is expanding at a different rate depending on how you measure it. This suggests that we are missing something fundamental, perhaps an early dark energy that gave the universe a push right after it was born. A new physics that is crying out to be discovered. And if that weren't enough with cosmology, Webb and TESS are finding things in our neighborhood that violate the rules of stellar evolution. Let me introduce you to Hala 8 Ursae Minoris b. This planet orbits a dying red giant star. We know that when these stars age, they swell up and swallow everything around them. Calculations suggest that Hala's star should have expanded beyond the planet's orbit. In other words, Hala should have been devoured, chewed up, and disintegrated. But there it is, orbiting peacefully. How did it survive? Is it a zombie planet? Or perhaps it's a second-generation planet born from the ashes of a violent stellar merger? And it's not the only one. There's also the forbidden planet TOI 5205b, a gas giant the size of Jupiter orbiting a tiny dwarf star. It's like watching a pea, the star, trying to hold up a watermelon, the planet. According to our theories of planetary formation, that star didn't have enough material to create such a monster. And yet it exists. So is physics broken? Do we have to throw out textbooks? No, it's better than that. The light that shouldn't exist is telling us that the universe is far more creative, dynamic, and strange than we thought. Perhaps the universe had a burst of dark energy in its youth. Perhaps the first stars were monsters made of dark matter. Perhaps black holes were born before galaxies, and not the other way around. The James Webb Telescope didn't give us the answers we expected. It gave us new questions. And in science, that's the most exciting thing that can happen, because it means we're on the verge of discovering something big. If thinking about dark stars and zombie planets has blown your mind, hit the like button. What's your theory? Do you think the Big Bang Theory is wrong? Or that we're missing a piece of the puzzle? Let me know in the comments. I read them all. Subscribe so you don't miss the next episode.